Hello everyone, and welcome to our forensic science course. Today, we are going to lay the foundation for everything we'll be discussing throughout this course by exploring the structure of the United States legal system, the criminal justice process, and how forensic science plays a critical role in achieving justice. My goal is to give you a comprehensive understanding of how laws are enforced, how trials unfold, and how forensic evidence is presented in courtrooms. So let's dive in. Forensic science applies scientific principles to legal questions, whether we're analyzing DNA, bloodstains, fingerprints, or digital evidence. It's all about uncovering the truth and ensuring justice is served. Forensic scientists are often called upon to provide clarity in cases where eyewitness testimony may be unreliable. This is particularly common in cases involving traumatic events, where human memory can be distorted. Forensic evidence is objective. It does not change its story under pressure. To understand the role of forensic evidence in our legal system, we must first grasp how our government operates. The United States government is built on the principle of separation of powers, divided into three branches. The legislative branch consists of the Congress, which is bicameral, consisting of two houses. There's a Senate with 100 senators, with 2 from each state. There's a House of Representatives with 435 voting members based on state population, plus non-voting members representing territories like Puerto Rico and Guam. The legislative branch creates the laws, which lay the groundwork for what is considered legal or illegal. I once collaborated with Congress to create new legislation against trafficking in persons. And this law was then signed by the President of the United States. It actually allowed for us to do better work in our investigations in this area. Then we have the executive branch. That is the President, along with federal agencies, and they ensure that laws are enforced. Agencies like the FBI and DEA are part of this branch, which is critical for national law enforcement. Then we have the judicial branch. This branch includes all federal and state courts interpreting laws to ensure that they align with the Constitution. This branch is vital in deciding whether laws and actions taken by law enforcement are actually constitutional. Law enforcement in the United States operates at several levels, each with their own responsibilities. We have federal agencies like the FBI, ATF, and DEA, and they handle cases involving federal laws. These can range from counterterrorism to complex financial crimes. I've had the opportunity to work on joint task forces with federal agencies, especially in cases that spanned multiple states. One memorable case involved coordinating with the FBI and several other state and local agencies to apprehend suspects involved in interstate fraud. We also have state law enforcement. State police and highway patrol enforce laws within state borders. They often assist local agencies with larger, more complex cases. The local law enforcement consists of city and county police, and they handle everything from traffic violations to local homicides. They are often the first responders to crime scenes. We also have tribal law enforcement. These agencies enforce laws on Native American reservations, operating under a unique legal framework that respects tribal sovereignty while collaborating with federal authorities. Our court system addresses both criminal and civil cases. Criminal law involves violations of statutory laws, ranging from minor infractions to major felonies like homicide or grand theft. Penalties can include fines, imprisonment, or even the death penalty in some states. Civil laws deal with disputes between individuals or entities. This includes cases related to contracts, property disputes, or torts. Tort law specifically covers civil wrongs where someone's actions caused harm or injury to another. This could range from car accidents to defamation cases. Then we have trial courts, and most cases start here. These courts determine the facts of the case through evidence and testimonies. If forensic evidence is involved, it's typically presented in these trial courts. Civil cases in these courts use the preponderance of the evidence standard, which is easier to meet than the beyond a reasonable doubt standard in criminal cases. When law enforcement officers have sufficient evidence, they may arrest a suspect. It's essential that officers follow due process, starting with reading the Miranda rights, if they intend to question the suspect in custody. This ensures that any statements made are admissible in court. If a suspect is simply detained without interrogation, Miranda doesn't apply. But once questioning begins, any statements made without the warning are inadmissible. I can remember a case where a detective failed to read Miranda rights before an interview. It nearly cost us a key confession. The suspect's personal details, fingerprints, and photographs are recorded at the time of arrest. A judge will then evaluate several factors before granting bail, such as the seriousness of the crime, the suspect's criminal history, employment status, and community ties. Prosecutors review evidence to decide on formal charges, and indictments may be issued by a grand jury. We then have an arraignment where the defendant hears the charges and enters a plea, either guilty or not guilty. We then have pretrial motions where both sides may argue to exclude evidence or dismiss charges. And then there's the trial, where evidence is presented, including forensic analysis. Witnesses are called for direct examination and cross-examination. After closing arguments, the jury will deliberate to reach a verdict. If there's no unanimous decision, it can result in what's called a hung jury. In court, witnesses are crucial for building a case. We have fact witnesses, and they share first-hand knowledge. We have expert witnesses, like forensic experts who provide opinions based on their specialized knowledge. And their testimonies must meet the standards set by the Daubert Standard or Federal Rule 702 to be considered reliable. Evidence is the backbone of forensic science. Physical evidence, which are items like weapons, fibers, and blood samples, or documentary evidence, which are contracts, emails, or digital files. And we have demonstrative evidence, which are visual aids used to clarify facts in court. Forensic scientists use the scientific method: observation, hypothesis, experimentation, and conclusion. This method ensures objectivity, whether examining DNA samples or analyzing digital footprints. In one case, we used a combination of digital forensics and DNA analysis to prove a suspect committed a particular heinous crime. That same evidence was used to reconvict 10 years later, after the defendant was granted the right to a retrial. He was again convicted of the crime. Now, let's take some time to explore a vital area in forensic science: physical evidence. In many criminal investigations, the question we need to answer is whether a specific piece of evidence can be definitively linked to a particular source. This leads us to an important question: can science prove that this evidence is unique and arises from a unique specific source? This is crucial in cases where we need to establish a direct link between the suspect and the crime scene. Let's look at some examples. Imagine a forensic scientist examining a bullet found at a crime scene. The scientist's job is to determine whether bullet A was fired from gun X to the exclusion of all other guns. Or take another example. Did fingerprint Z found on a windowsill belong to suspect S and no one else? The answer to these questions often hinges on specific scientific comparisons. To scientifically prove that evidence came from a specific source, forensic scientists compare it to a known standard or an exemplar. An exemplar is a sample produced by or derived from the standard. For example, in firearm analysis, the standard might be test-fired bullet from the suspect's gun. In DNA analysis, the standard is a DNA sample taken directly from the suspect. For fingerprints, the standard is a set of prints collected from the individual. This comparison helps determine whether the evidence matches the known standard. Let's consider another scenario. Imagine a crime scene investigator finds white powder The question is, can science prove that this powder is cocaine? Here we need chemical tests to confirm the identity of the substance. This is essential because a visual examination alone cannot determine the chemical composition. Now let's break down two important concepts: class characteristics and individual characteristics. Class characteristics refer to general features that place evidence into broad categories. For example, when we examine human beings, we can classify them by characteristics like gender, ethnicity, or even eye color. But these features do not make someone unique. For instance, knowing someone is a white male over 6 feet tall with green eyes helps narrow down a group, but it does not identify a single individual. In one investigation, we had a footprint at the crime scene. It was classified as belonging to a certain brand and size, which helped narrow a suspect pool. However, it wasn't enough to pinpoint the exact person who left the print. Individual characteristics, on the other hand, are unique to a particular item or person. For example, let's take fingerprints. No two people have identical fingerprints, making them a powerful tool for identification. Or DNA. Genetic profiles are unique except in identical twins, allowing for precise identification in criminal cases. Now imagine we have a group of men who are all over 6 feet 5 inches tall with green eyes. While that's a relatively rare set of characteristics, it's still not enough to identify a specific person. However, if we take a fingerprint from one of these individuals, we can definitively identify him to the exclusion of all others. This is where individual characteristics come into play. In forensic labs, we use a combination of class and individual characteristics to narrow down the possible sources of evidence. For example, in firearm analysis, the class characteristics of a bullet include its caliber and type. But to determine if it came from a specific gun, we examine individual characteristics like the striations left by the gun barrel. In DNA testing, the initial analysis may classify DNA into categories like gender or ethnicity, but a full genetic profile provides individual characteristics that can link a sample to one person. The scientific method is the backbone of forensic science. It involves a structured process of forming a hypothesis, conducting experiments. In a lab setting, forensic scientists apply this method to validate their techniques and ensure that results are accurate. However, not all forensic techniques can be subjected to the scientific method. For instance, the analysis of digital evidence or psychological profiling may rely more on logical conclusions derived from observation and reasoning. This is where inference comes into play. When a forensic scientist examines evidence, we often start with a hypothesis. For instance, did bullet A originate from gun X? Or did the blood sample come from suspect Y? We then test this hypothesis by comparing the evidence to known standards. The goal is to either confirm or refute the hypothesis. However, sometimes the evidence may not provide a clear answer. In such cases, forensic scientists may report findings using terms such as consistent with, associated with, cannot be excluded. These terms indicate that while evidence matches certain characteristics, there may not be enough individual characteristics to conclusively identify the source. I've worked on arson cases where the scientific method was combined with inference to determine the cause of the fire. By analyzing burn patterns and collecting samples, we could conclude whether it was accidental or even intentional. While the media often uses the term match to describe evidence, forensic scientists are more precise. Instead of saying something is a perfect match, we might report the probability that the evidence could have come from another source. This is especially true in complex cases like partial fingerprints or mixed DNA samples. Let's put it into context. Suppose we have a hypothesis that evidence A originated from suspect X. Depending on the type of evidence and its class and individual characteristics, the conclusion may fall into one of these categories. A confirmed match. Evidence A definitively came from source X. Or it's excluded, meaning evidence A could not have come from source X. Or it's inconclusive. Evidence A may have come from source X, but there isn't enough information to confirm or exclude it. In the crime lab, evidence is meticulously compared to known standards. For instance, in a fingerprint analysis, we compare the ridge patterns, bifurcations, and minutia points to a known sample. If enough individual characteristics align, we can confirm a match. However, if there's only a partial alignment, we may report it as consistent with rather than a definitive match. When we talk about chain of custody, maintaining unbroken chain of custody is essential to ensure that our evidence is admissible in court. Now, let's explore how forensic scientists interpret evidence and conduct tests. Understanding the processes behind analyzing evidence is crucial because it involves more than just looking at test results. We need to understand the nuances, the limitations, and methods that can impact how we interpret findings. Let's dive into the world of forensic tests, the scientific method, and the tools used to gather and analyze evidence. Let's start by discussing how forensic evidence is interpreted. After collecting evidence, the analysis conducted by forensic scientists needs to be thoroughly documented. In many situations, the test results are straightforward, either positive or negative. For example, a test might show that a substance is cocaine or it isn't. These results are considered objective data. Not all forensic analysis are black and white. Some tests involve interpretation, which means a degree of subjectivity comes into play. In these cases, forensic scientists must use their expertise and experience to offer educated opinions. For instance, in a fingerprint analysis, some patterns may not be clear-cut, especially if the print is partial or smudged. Similarly, in handwriting analysis, experts may need to consider numerous factors, such as slant, pressure, and letter formation, in order to offer an opinion on authorship. This is why, at times, two forensic experts might reach different conclusions based on the same set of data. It's not uncommon for experts to disagree, especially in cases involving complex evidence. Let's talk about some key terms you should be familiar with regarding testing. Positive and negative results. A positive result indicates that the substance being tested is present. A negative result means that the substance is not present. We also have presumptive versus confirmatory tests. In a presumptive test, these are preliminary screening tests. A positive result suggests a substance may be present, but confirmatory tests are needed for verification. For example, a presumptive test might detect blood at a crime scene, but further tests are required to confirm it is human blood. Then in confirmatory tests, these are more specific and are used to definitively identify a substance. They often involve different methodologies to ensure accuracy. Another distinction to be aware of is between qualitative and quantitative tests. In qualitative tests, these determine whether a substance is present or absent. For example, testing for the presence of drugs in a sample. In a quantitative test, this measures the amount of a substance present. For instance, determining the blood alcohol concentration in a suspect's bloodstream. Let's break down some terms related to test accuracy. We have false positive. This occurs when a test indicates the presence of a substance that is not actually there. Then we have false negative. This is when a test fails to detect a substance that is present. We have sensitivity, and this is a test's ability to correctly identify the presence of a substance. A highly sensitive test should always detect the substance if it's there. Then we have specificity, a test's ability to correctly identify only the substance in question, ensuring it does not falsely detect other substances. Ideally, we want tests that are both highly sensitive and highly specific. Forensic science relies on a variety of tools depending on the specialty. We have observation and documentation, and this is the cornerstone of forensic work. Proper documentation ensures evidence can be used in court. We have photography, and where high quality photos are essential for capturing crime scenes and evidence. In some cases, forensics photographers can serve as expert witnesses, testifying to the accuracy of their images. We have microscopy, and different types of microscopes are used depending on the level of magnification needed. Some examples are a dissecting microscope for lower magnification, light microscope for examining fine details, an electron microscope for ultra-high magnification, revealing details at a microscopic level. We also have collection and preservation. Proper collection and preservation of evidence are critical. The chain of custody must be maintained to ensure evidence is not tampered with or degraded. Let's consider a forensics profession. How about forensic photographers? They play a crucial role in capturing crime scenes accurately. High quality photographs can provide crucial evidence for reconstructing events. I've seen cases where photographs taken at the scene helped us identify crucial details, such as hidden evidence that wasn't noticed during the initial investigation. We've covered a lot today, from the fundamentals of the legal system to the role of forensic evidence in court. Now remember, forensic science is not just about solving crimes, it's about seeking truth and ensuring justice is served. I look forward to continuing this journey with you in our next module.